Hey everyone, in this video we're talking about a couple things. The first one is I'm going to show you a practical use for linear relations. We're going to talk about how to use let statements, how to tackle a word problem, and the method I'm going to show you for this particular word problem is going to be the elimination method. You could do exactly the same question using the substitution method, but in my opinion, for this specific question, it's easier to use elimination method, so that's what I'm going to use. So I made up this question. It's about fishing. So I've got a 7-ounce package of fishing lures contains 12 small lures and 10 large lures. A 4-ounce package contains 5 small lures and 15 large lures. How much does a single small lure weigh? First thing you need to do, look at the question and highlight or pick out any important pieces of information. So I know that in a 7-ounce package I get 12, and I'll use the symbol S for small lures, and 10, I'll use the symbol L for large lures. In a second package that weighs 4 ounces, I have 5 small lures and 15 large lures. So what I'm going to think is, how do I make that into an equation? Well, I'm going to say the 7 ounces is equivalent to 12 times S being the weight of the small lure plus 10 times L, with L being the weight of the large lure. 4 ounces is equivalent to 5 times S, 5 times the weight of the small lure, plus 15L, 15 times the weight of the large lure. So I've got two equations, and I think I'm just going to drop the ounces for now. We don't really need them. And we've got two equations. Now, the question says how much does a single small lure weigh? So S is what we're solving for. So I need a way to make the variable L go away, because I can't solve an equation that has two variables in it at the same time. So I'm going to use the elimination method. The elimination method says you subtract one equation from another. Well, I can't really, if I just subtracted now and did 12 minus 5, that would be 7S. 10 minus 15 would be negative 5L, and 7 minus 4 would be 3. I still have two variables left over, which is not what I want because that's not helping me solve. So I need to maybe multiply one of these equations, or maybe both of them, by some number, so that maybe our L's, when we subtract them, will get 0 instead of just some other number. So because it's the L's that I'm trying to make disappear, I'm going to turn 10 and 15 into the same number using multiply. What I'm going to do is that's 15, so I'm going to multiply everything in this equation by 15. That one is 10, so I'm going to multiply everything in the second equation by 10. When I do that, I get 15 times 7, which would be 105. Use the distributive property. You need to multiply everything by the number. 12 times 15 be equal to 180. S plus 15 times 10 will be 150L. We'll multiply everything in this equation by 10. 10 times 4 will be 40. 10 times 5 will be 50. And 10 times 15 would be 150. So now you can see we've got 150L in both of them. So when I subtract, 105 minus 40 will be 65. 180 minus 50 will be 130, S, and 150 minus 150 will be 0L. 0L, that's equivalent to nothing. So I don't even need to write it down. We've made L disappear. Now I have one variable and everything else is numbers. all I need to do is divide both sides by 130 so that my 130s cancel out, and I'll get S equals 65 divided by 130. And 65 divided by 130 is equal to 0.5. So every one of my small lures weighed 0.5 ounces. Now let's say the question asked us then, what's the weight of the large lure? You don't need to do elimination method again and this time try and cancel out your S's. You could, it would work, but it's probably not the fastest or the easiest way to do it. Let's look at one of our original equations. How about this one? 4 equals 5S plus 15L. So I know what S is now. I know that S is 0.5. And now I've got 5 times 0.5 will just be equal to 2.5. If I subtract 2.5 from both sides, 4 minus 2.5, I guess that's equal to 1.5. When I subtract 2.5 from what's over here, my 2.5 will go away, and all of that's equal to 15L. Divide both sides by 15, and I'll get L equals 1.5 divided by 15 would be 0.1. Now, a good idea is once you have what S equals, and once you have what L equals, plug them into the other equation just to double check that it's still going to work out just fine. Let's go here. Okay. So this equation up here, 7 equals 12S plus 10L. I know S is 0.5, that's what I found. 12 times 0.5 will be 6. 10 times 0.1 is equal to 1. Does 6 plus 1 equal 7? Yeah, 7 equals 7, which is true, so I know that all of the answers I found are right because they work when I plug them in to the equations that I was given.